Hi everyone. So welcome back to these recorded lessons. Uh, in the last video, I ended by looking at the difference of two squares, and with this video, I'm going to go back to factorization, and after that, we keep going in the book. So if you look at the problems that I have in problem 11, I am going to start from problem E. Problem E. I think that for these problems, some of them we did them, some of them, not all of them though, some of them we did them and some we didn't, because I thought that, it's impossible for us to do all of them, but at least we should do some of them. So sometimes even before we go to problem E, we could also look at problem D. So with problem D, here we have 3x squared plus 15x plus 18. Now, if you divide through by 3, it's going to help. Why? Because 3 is common. 3 is common in all the three numbers on there. You have 3, 15, and 18. Or if you get 3 out, you can pull 3 out also. You can pull 3 out. If not, if you decide to divide through by 3, let's say that I'm going to pull 3 out. If I pull 3 out, I'm going to have x squared plus 5x plus 6. So this becomes a quadratic expression that I have to factorize. I think yesterday we did something like this. I'm going to take it to the top. So 3x squared plus 5x plus 6. Now, for my AC method, remember, AC here is 1, because we've got 1 here next to the x squared. So 1, we don't usually write the 1, but for explanation's sake, I'm going to put the 1 there. So 1 times 6, which gives us 6, right? So we need two numbers that would multiply to give us 6. And then we have 5 for B, two numbers that would add up to get 6. So with these, I think that it's going to be, because both are positive, it's going to be 3 times 2, 3 plus 2. Okay, so that allows us, the 3 is still outside. We've got x squared plus 3x plus 2x plus 6. So you take these two, you take those two. So x out, we have x here. So x times x gives x squared plus 3 plus 2, and then we've got x plus 3. So with this, we can pull x plus 3 out, right? X plus 3 is common here. So if you pull x plus 3 out, you're going to have x here plus 2. So that is what you have, x plus 3 and then x plus 2. These are multiplying. Okay, so sometimes you have to fix this a little bit, and we still have the 3 out here. Yep, I almost forgot that. We still have the 3 out in here. We still have the 3. Okay. Now, someone might decide to divide through by 3. That is fine. Divide through by 3 so that the 3 will go away. But you could also do it this way. All right. Now let's keep going. Let me talk about problem E for a little bit. Problem E, we've got x cubed minus x squared minus 12x. So someone is going to say, how do I deal with this? Now remember, x is common, right? X is common. So you can divide through by x, or you factor x out. If I decide to divide through by x, I divide this by x, I divide that by x, I divide this by x. So this cancels, this cancel, and this will cancel, this will change to x squared, right? So I have x squared minus x minus 12. So now I have a quadratic. So sometimes you have to think about it a little bit. How can I decrease this? How can I decrease this? Bring it down a little bit, okay? Because you know that we are dealing with quadratic in this section, so you should get a quadratic some way, somehow. So you look for the factor, you divide through by it, or you factorize it out, and then you have this. So now you should try and then solve this. So with the AC method, I have 1 here. So 1 times negative 12 gives me negative 12. So I need 2 numbers. And then I've got negative, so minus 8. I need 2 numbers that would add to give negative 1. So what are those numbers? Negative 4 times 3. Negative 4 plus 3. These 2 numbers would help me solve that. Okay, so now you use those to solve. Remember that these are expressions, but in the end we are going to look at equations where it's equated to 0. That means that we are finding the x, or the x-intercept, or the horizontal intercept when it's equated to 0, because that means that y is 0. Okay, so we will do that in a little bit. Now again, I'm going to go to the whiteboard and then talk about some general expressions that you have to factorize. So let's say that you are given 6x cubed plus 18x squared plus 24x. And it tells you to factor this completely. How do you do that? Now, first of all, you look for the factor, the greatest common factor between these 3 numbers. So I've got 6, 18, 24. Remember, I'm looking for the greatest common factor. Yes, 2 can go into all 3 numbers. Yes, that is true. Again, 3 can go into all 3 numbers, but are those the greatest common factors? No. 6 can go into all 3 numbers. Is that the greatest common factor? Yes. Why? Because we've got 6 here. We've got a number 6 here. So that's the greatest we can go, right? So I'm going to factor out 6. That is going to be my first one. Now, what about x? I've got x cubed, I've got x squared, I've got x. Can I factor out something? Yes. And that should be x. Right? That should be x. Then I bring my parentheses. I've got x squared here plus 6 times what gives 18? 3. 6 times what gives x squared? It's going to be x plus 6 goes into 24 4 times. And I only got an x here. I've got an x outside, so that's it for me. Again, after this, check to make sure. Multiply them again and see if you're going to get what you have at the top. Multiply them again or expand them again. Okay, so 6x times x squared should give me 6x cubed. 6x times 3x should give me 18x squared. 6x times 4 should give me 24x. Now, what about if I have 15x to the power 4 minus 24? And it says factor out, factor completely. How do you do this? Again, I look at the numbers. 15x to the power 4 minus 24. What is the common factor? The greatest common factor is 3. X to the power 4, but I don't have an x with the 24, so that's it. So 3 goes into 15 5 times. I still have the x to the power 4. Again, check to make sure by multiplying. 3 times 5 is 15. You have the x to the power 4. Minus 3 times what gives 24 is 8. So this has been factored completely. Okay, so that's how you deal with these kinds of problems. Now let's try another one. So let's say that we have we have 8x to the power 4 minus minus, let's do 12 x to the power 5 plus 36 x to the power 6. Factor out completely. So again, you compare and find the greatest common factor. So I have 8, I have 12, I have 36. So I know 2 can go into all of them, but 2 is not going to be the greatest common factor. What about 4? 4 can go into 8, 4 can go into 12, 4 can go into 36. So yes, I got it. So 4. Now what about the x's? What about these? So I've got x to the power 4, x to the power 5, x to the power 6. When I look at them, I think x to the power 4 will do it. X to the power 4. Now 4 times what gives 8 is 2. Now x to the power 4, x to the power 4, that is 1, so I'm going to leave it as minus. 4 goes into 12 3 times. X to the power 4 goes into that. What times x to the power 4 give you x to the power 5x? Plus 4 goes into 36 9 times. X to the power 4 times what will give you x to the power 6 is x to the power 2. And that's it. I'm done. So that is how to deal with these kinds of problems as well. These kind of problems as well. Now we're going to try one more. We're going to try one more. That is going to be 25 x to the power 5 minus 45 x to the power 2. Now you are supposed to factorize this completely. So how do we do that? Again, you look for the greatest common factor between 25 and 45. What is that going to be? 5. What about x to the power 5 and x to the power 2? The greatest common is going to be x squared. Okay? Because x squared can go into x to the power 5. Now you bring the parentheses. 5 goes into 25 how many times? 5 times. You've got x cubed. Minus 5 goes into 45 how many times? 9 times. You have x squared going to x squared 1 time, and that's it. That's all you do. So you have to know your factors. You have to know your factors. Okay? You have to know your factors. What goes into both of them? What goes into both of them? You have to know that. All right. Maybe one last one. So let's do 12y to the power 4 minus we'll do 50y. So what about this one? So again, I'm going to look for the greatest common factor. How? So to go back, so I have 12. What are the factors of 12? 1, 2. Again, a factor is a number that can go into another number completely. So it divides into another number, and then you get a number without a remainder. So 1 will go into 12 times, 2 will go into 12 6 times, right? 3 will go into 12 4 times, 4 will go into 12 3 times, and then 12. Now, what about 50? I have 1, 2, 5, 10, 25, 50. So if you look at this problem with 50, what is the greatest common factor? So you compare the two factors. So 12 is here, it's 12 because we are looking at the greatest common factor. So you start from the numbers. Is 12 common? No. 6? No. 4? No. 3? No. 2? Yes, 2 is common. So 2 is going to be the greatest common factor here. 2 is going to be the greatest common factor. So I'm going to have 2 out. Now y to the power 4 and y, I'm going to have y. So 2y. And then 2y times what gives 12y to the power 4? 6y cubed minus 2 goes into 50 25 times. Y goes into y 1 time. And that's it. That's all. All right. So let's keep going. Let's go to the book and then continue with what we have been doing. All right. Okay. Now let's look at this problem, problem F. Let's look at that one. So here, remember, we've got 2x cubed plus 16x squared plus 30x. Now, I know that I have some numbers that are common in this, right? I could see that. So I could decrease this by dividing through by some numbers or factoring those out. So I would see that 2 is common, okay? 2 is common, and then I have x cubed, x squared, x. X is also common. So I divide this by 2x, divide that by 2x, divide that by 2x. If I do that, 2 will cancel 2, x will cancel this, and I have x squared. 2 will cancel this 8 times. X will cancel that, I have x. Now here, 2x will cancel this, I have 15. So I'm going to have x squared for the first one plus 8x plus 15, like that, plus 15. Now I've got a quadratic function, plus 8x plus 15. Now, from the AC method, if I've got a 1 here, 1 times 15 is 15. I need 2 numbers. And then I've got 8 for B. And this clearly is 3 times 5, 3 plus 5. So this gives me x squared plus x plus 5x plus 15. These two go together, those two go together. So x out, because x is common. X times x gives x squared, x times 3 gives 3x plus 5 out. 5 is common, right, amongst the two or between the two. So you have 5x plus 3. Again, what is in the parentheses? What is in the parentheses should go together. What is in the parentheses should go together. So I have x plus 3, x plus 5. So some of them you have to work on it a little bit and then fix it a little bit, and then you're going to get your factors, what you need. Okay, we're going to have what you need. Now, someone might also decide to factor out the 2x, what we started with. So you still have the 2x out like that. You still have 2x out like that. All right, let's keep going. We talked about the difference between two squares. I would say that let's quickly look at this example. 4x squared minus 9. 4x squared minus 9. So here I don't have enough space, but I'm going to do it here. 4x squared minus 9. Can I use a difference between two squares? Yes. Why? Because I could change this to a square. I have 2x all squared minus 9 is 3 squared, right? And the rule says once you have two squares subtracting difference of two squares, then you're good. So this should give me, I'm going to do that here, 2x plus 3, 2x minus 3, and that's it. So if you can change one of them to a square, I mean that because you have 9, you know that 9 is a square of 3, okay? So you change that and then you solve that, and that's it. That's all you do. That's all you do for these problems. X squared minus 1, yes, because 1 can be 1 squared, right? So you have difference between two squares. All right. Now, we did talk about this a little bit, but we're going to do that today too. Now, we have, for the past one that we did, usually A is equal to 1. Here, A is not equal to 1, but it's the same rule, same rule, same rule. So I'm going to say, let's do this one. 2x squared plus 9x plus 7. So from the AC method, 2 times 7 gives 14. You need two numbers that would multiply to give you that. And then our B is 9. You need two numbers that would add to do that. Clearly, it's 2 times 7 is 14. 2 plus 7 is what? It's 9. So I'm going to do it here. 2x squared plus 2x plus 7x plus 7. So 2x squared and 2x, I'm going to have 2x out, and then x here plus 1. Plus this and that 7 will come out. I have x plus 1. So if I bring out x plus 1, then I'm going to have the 2x left here, and then I'm going to have the plus 7 left here. Again, these in the parentheses should be the same. Should be the same. So here we are going to have x plus 1, 2x plus 7. Okay. Now, what about this one here? We've got 3x squared plus 4x plus 1. So the AC method says 3 times 1 gives 3. You need two numbers that would multiply to give us 3. And then B is 4. And those same numbers should add to give us 4. So it's 4 times 1. 3 plus 1. So we have that. So it's 3x squared plus 3x plus x plus 1. So 3x squared plus 3x, that gives 3x, 3x, okay? 3x times what gives you 3x squared times x plus 1, because you've got 3x here. Now, plus x and then plus 1. What is common is just 1. So you could write the 1 here, or you could just leave it alone. You have x plus 1. Now, the common between this is x plus 1. And then you have your 3x here, plus what? Here you have plus 1, even though you don't see it, but it's plus 1. And you are done with it. You are done. All right? Okay. Now, we are going into quadratic equations. We are moving from expressions to equations. Now, if you look at this problem, 5x squared minus 10x equals 0. Now you have equal 0. Now, to factorize this and solve for x, 5x squared and 10x. 5 and 10, what is common is 5. X squared and x, what is common is x. Then you have the parenthesis. 5x times what gives you 5x squared is x. 5x times what gives you that is minus 2 equals 0. So 5x, this is how you do it. 5x equals 0. And then this guy, x minus 2 equals 0. So you've got two of them. Okay. So you have 5x equals 0. So if you solve for that, you're solving for x. You divide by 5, you divide by 5. So x becomes what? 0. X is 0. And then what about x minus 2 equals 0? You could move this to the other side. For x to stand alone, x equals 2. So x equals 0, or x equals 2. X equals 0, or x equals 2. Again, the calculator can solve this for you. The calculator can also do this job for you. Okay, the calculator can do this, and then also it can also help you get the graph out there. And in doing this, remember that what we call applying the zero product principle is used. It's used because if you have this equated to zero, if you have this to be equated to zero, what does it mean? It means that because you have 5x squared plus 10x equals 0. Now, we did 5x out, x plus 2 equals 0, or it was a minus, but let's take it as a plus. It's okay. Now, at this point, if you take 5x, if you take 5x to be equal to a, and x plus 2 to be equal to b. Okay, so 5x is a, x plus 2 is b, so we have a times b equals 0. Because we have this here equals 0 here, it means that either a or b is 0, right? Because if a is 0, we have 0 times b equals what? 0. If b is 0, we have a times 0 equals 0. That's it, right? So if we have 5x times x plus 2 equals 0, we could either say 5x equals 0 or x plus 2 equals 0. So we solve for either of them, I mean both of them. So 5x equals 0, you divide by 5. We're solving for x, you divide by 5. X equals 0. X plus 2 equals 0. You move this, or you subtract 2 on both sides. X becomes negative 2. So equals 0 or negative 2 or negative 2, like that. Now, we could also graph this, as I was saying, we could graph this, put this in a graph, and that would also help us. Now, let me share my screen. Oops. All right. So let's say that if we decide to put this 5x squared, so 5x squared minus 10x okay, is what we have, equals 0. Because it's equals 0, the next part of it is going to be our y2, so 0 is here, so it's equal to 0. You set that up. Now we could check the window and then try and do a standard window, minus 10 to 10. Oops. Minus 10 to 10, and then leave the scale as that, minus 10 again to 10, and then let's go to graph. Let's see what we get. So we have the graph. We have the graph. Okay, we have the graph. Now, the next thing that I would say that you should do is to find the horizontal intercept, that is the x values. And that, when you go to media examples, it teaches you how to do that. But I will do one or two of them so that you understand and appreciate what is going on here. to understand and appreciate what is going on. All right, so we are going to go back to our workbook. And then you keep going from there. All right, just give me about a minute because I've got to be switching from here to there. All right, so if we are looking at okay, just give me about a minute again. This is a very large document, so it takes time to load. All right, there we go. So because we've talked about zero product principle, I am going to keep going. Okay, now here, especially looking at quadratic equations from here, what you should see here is that when you have an equation like this, you can solve it, okay, algebraically like what I did, and then you could also go to the calculator and then get what you need. Now, if we look at the next problem, which is x squared minus 7x plus 12 equals 2. X squared minus 12x plus 12 equals 2. Now, to set this calculator, this whole thing can be your y1, and the 2 here can be your y2. You set it up that way in a calculator or on the calculator. So that's how you do it. Okay, that's how you do it. But again, you could also solve this algebraically by fixing it a little bit, like what was done here. So x squared minus 7x plus 12 equals 2. Now we could move the 2 to this side, right? We could move the 2 here. Let me erase this and then so x squared minus 7x plus 12 equals 2. So x squared minus 7x plus 12. You move the 2 to this side, minus 2 equals 0. Oops, equals 0. So 12 minus 2 gives a 10. So we have x squared minus 7x plus 10 equals 0. That's what we have. Okay, so you solve that using the AC method. You solve that using the AC method. Okay, solve that using the AC method. All right. At this point, I'm going to end this video, but before that, I want to look at this quadratic x squared minus 7x plus 10 equals 0. Now, how do we solve this? Remember the AC method. We've got 1 here, so 1 times 10, 10 equals that. We need two numbers that would multiply, and then we need two numbers that would add up to give us that. So here we have -2, -5, right? Negative times negative gives a positive. Then here we have -2, -5. You can put that in parentheses. So we've got the 2. So x squared minus 2x minus 5x plus 10 equals 0. Okay, so we have x out, x minus 2. We already talked about this. You bring the minus 5 out. Here you have to be careful. X, and then what about 10? It's positive 10, so this becomes -2 equals 0. Again, when you are getting confused, look at this, because you know that the parenthesis, what is in there, should be the same. So x minus 2, because minus 5 times minus 2 should give you a positive 10. Make sure you check. Make sure you check. So that allows me to do this. X minus 2, x minus 5 equals 0. So x minus 2 equals 0, or x minus 5 equals 0. So x equals 2, x equals 5, or x equals 5. That's how you do it. So keep on looking at these. I'm going to add another video also, and then also deal with how to use calculator to get what we call the intersection. Go to my Open Math, watch the videos. The videos also teach you how to do all that. All right. Thank you so much. Send me your questions. All right. Send me your questions, and I'm ready to answer all of them. Thank you.